Find the seismic design category. In this problem, a hospital is located at 37 degrees north latitude, 89 degrees west longitude, in western Kentucky. The shear wave velocity of the soil is 6,000 feet per second. The seismic design category is defined in section 11.6 of ASCE 7. Table 11.6-1 in ASCE 7 assigns a seismic design category based on the occupancy category and the short period response acceleration parameter, SDS. Table 11.6-2 in ASCE 7 assigns a seismic design category based on the occupancy category and the 1-second response acceleration parameter, SD1. Since seismic design category F requires the most seismic reinforcement and seismic design category A requires the least seismic reinforcement, the table which prescribes the more conservative seismic design category governs the analysis. For example, if Table 11.6-1 prescribes seismic design category B and Table 11.6-2 prescribes seismic design category C, then the seismic design category is C. Also, if the 1-second spectral response acceleration, S1, is greater than 0.75, then the seismic design category is either E or F, which then depends on the occupancy category. One parameter we'll need to solve for in this problem is the occupancy category. Table 1604.5 in the 2006 International Building Code defines the occupancy category of buildings and other structures. Occupancy category type 1 includes buildings and structures which pose a low hazard to life in the event of failure. Occupancy category type 2 includes all buildings and structures whose occupancy category is not defined as occupancy categories 1, 3, or 4. Occupancy category type 3 includes all buildings which pose a substantial hazard to life in the event of failure, such as assembly halls, schools, jails, and other public facilities not included in occupancy category type 4. Occupancy category type 4 includes buildings and other structures designated as essential facilities, such as hospitals with surgery and emergency treatment, police and fire stations, and disaster shelters, and so on. The table 1604.5 shown here is only an excerpt from the entire table found in the code. Since our building in western Kentucky is a hospital, it is designated as having an occupancy category type 4. The occupancy category, short period and 1-second design response acceleration parameters, SDS and SD1, are also required to determine the seismic design category from tables 11.6-1 and 11.6-2 of ASCE 7. We have just determined the occupancy category is type 4, but we don't yet know the values of SD1 or SDS. We'll also need to check the 1-second design spectral response acceleration in case the seismic design category is E or F. The 3 unknown values can be determined one at a time. For example, the short period design spectral acceleration, SDS, equals 2/3 times the short period site coefficient, FA, times the short period spectral response acceleration, SS. The short period site coefficient, FA, is determined using the site class, Table 11.4-1 from ASCE 7, and the short period spectral response acceleration. The site class is determined using Table 1613.5.2 in IBC 2006, and a property of the soil, such as the shear wave velocity, V bar S. The short period spectral response acceleration can be determined using Figure 1613.5, number 7, from the IBC 2006, and knowledge of the structure's location. The 1-second design spectral acceleration equals 2/3 times the 1-second site coefficient, also called the long period site coefficient, times the 1-second spectral response acceleration, S1. Solving for these two terms is similar to the previous equation. The 1-second spectral response acceleration, S1, can be determined with Figure 1613.5, number 8, and knowledge of the structure's location. From before, we know that if S1 is at least 0.75, then the seismic design category is E or F, and we don't need to evaluate SDS or SD1. When looking up the location of the hospital in Figure 1613.5, number 8, we learn S1 equals 0.89. Therefore, we don't need to evaluate the short period or the 1-second design spectral acceleration parameters, SD1 or SDS. And we also won't need to use Table 11.6-1 or Table 11.6-2 because we know the seismic design category is either Type E or Type F, which depends on the occupancy category. From earlier in the problem, we determined the occupancy category for a hospital is Type 4, which means the seismic design category is F. When reviewing the possible solutions, the answer is F.